Okay, let's keep going and talk about equivalent units. So because the units are all the same, instead of job costing into each different product, we can just talk about equivalent units of production. So equivalent units of production are the product of the number of partially completed units and the percentage of actually completed units. So when we start thinking about this, we go, okay, if everything's the same, if I want to know what the costs are, I have so many that I've completed, so I have cost for those, and then I have some cost for some partially completed units, but they're all the same. So it doesn't really matter where in the process they are, I can get a percent completion on them, and therefore I will know what the cost will be. So the example here, the obvious example is 2 half-completed units are the equivalent to 1 product. And so if 10,000 units are 70% complete, that's equivalent to 7,000 complete units. So you can see the percentage of completion method is how far all these units complete, and then add that to however many units you have completely complete, and that will give you the number of units that you produced over that time. And of course that will account for your costs, and we'll get into that in just a second. So let's take an example of this. In the current period, Jones started 15,000 units. They started 15,000 units. Doesn't mean they completed them. They started production of 15,000 units. They completed 10,000, that's good, leaving 5,000 units in process, 30% complete. So we finished 10,000, we know how to cost those, that's equivalent units, that's 100%. And then the other units, these 5,000, were only 30% complete. So 30% of 5,000 would be 1150, and we add that to 10,000, and we get the answer, which of course is 11,500 units. So 10,000 units plus 5,000 units times 30% is 11,500 equivalent units. And so you can see the percentage of completion model is pretty straightforward to calculate. It's not a calculation problem. Knowing exactly how much is complete, percent complete, is going to be important to be fairly accurate. But you can see how you can get to the equivalent units. Now this clearly wouldn't work with job costing because all the job costs are going to be different. But if it's a bottle of Coca-Cola, if there's 5,000 that are in work in progress and they're 30% complete, well, then you've got a pretty good idea of how much work you did over that period. Now there's 2 ways to calculate the equivalent units. The first one is the first in, first out method, or FIFO. That's covered in your appendix, and we're going to leave it in your appendix for this class. And we're going to use the weighted average method. This is the method that's in the main chapter of your book, and it's the easiest. It might not be quite as accurate as FIFO. Certainly you're going to have different costs at different time periods, but nevertheless, weighted average makes it just lots easier to handle calculation-wise. So let's look at a couple of things about the weighted average method. The first thing is it makes no distinction between work done in prior or current period. In fact, it blends together the units and cost from prior and current periods. Now we can do this because all the units are the same. Coke in May is the same as Coke in June. So if there's leftover work in progress in May and it starts June, we're good with that. We just keep going. So we don't care if it's we've done in the prior period or not, because it's going to be the same thing over and over again. It also determines equivalent units of production for a department by adding together the number of units transferred out plus the equivalent units in ending work in progress inventory. So the units of production for a department are how much you got rid of and what's left over at the end. So if we left over in our last example 5,000 units at 30%, you'd have 150 units, 1,150 units, sorry, 1,150 units that were transferred out, are not transferred out, that are work in progress, plus the 10,000 units. That would be your equivalent units of 11,500 for that department. If we go past that, there's a little bit of issue here with direct labor. I'm going to bring this up, and I want you to, I'm going to suggest you watch a video too. When we start talking about doing things over and over and over again, it becomes very mechanical. And when it becomes very mechanical, we tend to let machines do it. So when we start thinking about machines doing things and it becoming mechanical, we get robots involved and so on, and labor becomes a much, much, much smaller portion of your overall costs. So when we do that, what are we going to do with labor? Are we really going to break it out to a separate thing? And in fact, many times we don't. We take labor, and this would be the breakdown here. Small direct labor, lots of direct materials and manufacturing overhead. And what we do with the direct labor is we just move that over and put the direct over, and we call overhead and direct labor together, we call that conversion. And so we have materials and we have conversion. And the conversion factor includes the labor, but also includes all of the overhead associated with the robots and the rest of the things. So what I'd suggest you do, just to see this, is to look at the video that I've put in the class on Tesla. And we all know Tesla, the electric car company. And they did Wired magazine did a video on it, really well done video on how they go through the production line and how automated it is. And you should easily note that there are very few people in this line. It works wonders. I mean, the material's moving through the plant on robots and nobody's involved in it. And so you think about direct labor, you're like, well, yeah, that's going to be a very small cost in this overall situation to build this car. So we just throw the direct labor into the manufacturing overhead, which of course is covering all the robots because it's not material. The robots are manufacturing overhead. And so we just call that conversion cost. It's converting the material into the final product. And so we kind of merge all those together in the process costs. That's certainly not going to be true in a job cost because or any job cost, because the production isn't uniform. It's different for everything that they make. So process costing lends itself to more mechanical processes. Therefore, we can throw the direct labor, which becomes a smaller portion of the overall cost, into the manufacturing overhead and just call it conversion costs. So let's take that and go forward and look at some examples.